Hello, so I hope I'm audible, and today we are going to be building or rather revisiting procedural wall and fences because when we started this series with the procedural wall building, I was taking a different approach and I was facing an issue with this. So if you have not watched the first live stream on this series, then you can check that out. I was facing an issue where uh, I had this line and it was not rotating in the right direction. One of the reasons was that I was getting a little bit confused since there were two different actors involved, and the right approach is to have a base actor for the spline and then derive the wall actor because I thought that the code is going to be repetitive because all the other components, all the other types of different actors may also use the spline to create a path on. But then, while designing the procedural pane, it occurred to me that why not create a base actor that can be a spline and then derive any other actor on top of that. That will obviously make things much less complicated. So we did that. I am going to rerun this code and show you everything how it was done today. And if time permits, we are going to continue building that, and then I am going to also modify this to create this inside the same actor instead. The reason I am going to rerun the fence is because for the last stream, I had some audio issues. I don't know if the audio issues is still here over here in this. Hello. I am not sure if the audio issue is still persisting, but I believe it's not. And so let's continue. Let's take a look into the fence. So over here, this is the source actor I created, procedural arch base. This has this spline component, and I will also show you the yeah TPP code over here. So here I'm defining the spline component, right? So this line is kind of important because you would want the spline to be editable when you're moving. So if you check out this fence, so the spline is actually, I mean, this can be editable. So if you don't set this to true, you may not be able to modify the spline point. Got it? All right. So and over here, I have also set a couple of parameters. I want to specify if the spline should be curved or not because I may want, I mean, especially for the walls, when I want the spline lines to be linear and not curved. But let's just show you how I'm doing it. So if it is curved, then there is a curviness in the fence as well. You can see over here. Okay. If it is not curved, then this is going to be a complete straight line. Simple enough. Okay, and with the hash fixed that to true, I won't be able to move the spine points along the z axis. If it is set to false, then this will happen. Okay, it set it back to true. And let's see how this is constructed. And you have the on construction. So if you're familiar with Blueprint's construction script, then construction script, you are already aware that construction script is anything that happens within the editor, or the rather the construction of the a given actor. And when you are calling the event begin play instance, so that is going to trigger whenever a play button is pressed, but not before that. So here also construction, when you use this on virtual void on construction, that means that your script is going to run within the editor itself. And but in C++, you have this additional function, post edit change property. And if you write anything inside that function, then you will have an option to only change the part of the code that is related to a certain property. For example, if I set the hash fixed that to true, then I can just use this post edit change property to set the z value. For example, if you look into the z code, here is the code for the fixed z. So I can simply, I mean, if I have any other code as well, so here it is just updating the spline position, not doing anything else. That's why I have not specifically added anything in the edit change property. But let's say I have a lot of complexity going on and I just want to execute this part of the code, so I can easily do that in here. So don't worry, we will, when we are actually having any use case for this, then we are definitely going to be using the post edit change property later on. But for now it's fine. We just need this line as to be as a base class, and our main functionalities are going to be in the derived class, which is the procedural frames.h. So this class has been derived from the procedural algebra class. Okay. So over here, welcome aboard. As we said, so over here you have the, yeah, you have this structure. Uh, so let me explain how fence works in real life. So if you take a look into here the fence diagram, let's just open this. You can check this out. So different types of fences are there. Usually you have a combination of vertical rails or beams, and then you may also have horizontal beams depending on the type of fences. But usually this is what happens, and some of the fences may also have this gate. So there are gates in between the fences, and then they have the vertical columns separating the gates. I mean, these are not gates; these are just walls, but there may also be gates along the fences. So a lot of possibilities when it comes to creating fences, right? So the way I have designed this is like I have a enum that is going to define if I want our fence meshes to be vertical or horizontal. If it is vertical, then it's going to create this vertical strip. If it is horizontal, then it's going to create a horizontal strip. A single fence can have many different types of beams. That's how I have set this up. So, and then we have the fence mesh info. Each of these is going to contain information of a single type of beam. For example, here you have the static mesh, then you have a dimension, then orientation by default is vertical, and then distance may indicates the distance between the two fences, right? When you are designing this wall, there is absolutely no distance, but entire uh, the entire distance is actually covered by the dimension of the wall itself. So we are going to figure that out as well. So right, so, and over here you have the main column and you have a set of secondary mesh info. So secondary, any other additional mesh. So you will always typically have a main mesh, which can be anything. It can be the this main column, or it can also be this walls. It can be the horizontal beam. However you want to design your frame. So this is always going to be there. On top of that, if you want additional mesh, which is typically going to be the case, you may want to have a vertical array of beams as the main columns and then a set of horizontal array of beams as the additional column. In that case, you only need to add one extra element in this array. Okay, so again, I have this construction and then I have a couple of functions. So let's see what these are doing over here. Generator frames is going to get the spline length and then it is going to arrange the fence along the given spline length. For example, let's say you have a spline length of 1000 and it is actually going to check the distance of the that you have defined for your main column. Over here you have defined the distance. So your main column has this distance property. It is going to determine like what is going to be the next distance, and then based on that it is actually so creating the fence column. Okay. So and this is the main column being created, and this is a secondary a set of secondary columns is being created. So if you don't have any secondary columns, let's consider you only have the main column. In this case, this is the function that we need to look into. So here I am what I'm doing is I'm creating the fence component from the given fence mesh, and then over here, okay, this is very important function because like for example, you may have different types of meshes, and each mesh can have different pivotal location, and also mesh dimension can be different, but I don't want to have different dimensions in here. If I'm specifying then this has to be 25 by 360, it means that it has to be 25 unreal units in the length, 25 unreal units which is typically centimeter in width, and then 316 in the height. So that's it. If some mesh is going to be too large, I don't want that to mess up my dimension calculation. All right, so that's why I have to calculate the relative dimensions of every mesh by using this function. If you go inside this function, you can see I'm getting the underlying static mesh of this, and then I'm getting the bounding box, and then this is going to calculate the difference between the max and the mean bound, and then it's going to return the difference. So what am I going to do with the difference? Let's see. So this becomes your mesh dimensions, and your desired dimension is your the dimension that you're providing over here. All right, here you're providing the desired dimension, and then okay, this is just a calculation of max dimension in case of horizontal and vertical. But what you are actually doing is you are getting the scale from the dimension. So here is the function which is getting your original static mesh dimension, then the dimension that you are defining, and then it is calculating the relative scale for your dimension. So for example, if you have designed a mesh in your 3D application so that it's too large in terms of Unreal units, then the scale is automatically going to reduce because the scale is always being divided with the dimension. So if your mesh is actually having uh, height of 1000 Unreal units, then its scale is going to be 1/10 along z-axis as compared to a mesh that has 100 Unreal units. So something like that. So scale is always readjusted to ensure that any mesh you're choosing over here stays exactly the same. Like even if you choose this mesh, it has to have exact the same dimension. It doesn't move, it doesn't shift, it doesn't also change its scale. That's about it. So you can only change its scale, I mean its height when you are adding the value along the z-axis. Okay, like this. All right. So now we will go back to our original function. So here I am also setting the rotation. I'm like I mentioned this fixed set. If the fixed set is set to true, then the location is going to be along the z-axis is going to be 0. All right. And then in that case, I mean, this is also not required because I am also fixing the spline point itself. But this was just in case because when you are changing your typically when you don't have a fixed spline point, when you are changing your spline location along the spline point location along the z-axis, then your desired rotation is also going to change. So this rotation value is actually your where it is. It's coming from here. So yeah, secondary rotation. This one get rotation at distance along spline. So this is how you're getting the rotation. So when you are fixing the z, so the rotation along the z axis is also not going to be considered. So don't worry about that. All right. So in this case, the desired rotation is always going to be the this rotation. The like if the spline is turning, so it's going to be like 90-degree rotation, something like that. All right. If the spline is curved in nature over here, then the rotation is going to be the tangent rotation as calculated from here, right? And finally, the desired location is going to be the yes. So here one thing I want to mention just how I have adjusted the dimension because each and every mesh can have different dimension and we have to take that into account. Similarly, each and every mesh can have a different pivotal offset and we also have to take that account into account because for some mesh the pivot may be in the center, for some mesh the pivot may be in the bottom. Okay. So in that case, I don't want to uh, have a have this like shift left and right that will make the fence very unstable if you are changing any mesh. So I want that to start at exactly the same location, and for that I have to also adjust the uh, adjust the desired location in terms of the how far, I mean what is the actual pivotal location. So let's see what this is doing. This is getting the component location. So now remember that I am first adjusting the scale. I'm first adjusting the scale and then I'm adjusting the location. So what happens over here? The component location is also taking into account that you are changing the scale. Typically, if the pivot is in the center and you are changing the scale, then the pivot is going to shift towards the bound origin, because origin is also moving when the scale is moving. So that's why you have to first ensure that you are setting the scale and then you are setting the location. Okay, so I'm getting the component location, and then this is important. I'm getting the center, and then I'm subtracting that with the extent to get the relative center, and then I am subtracting the relative center with the actual component location to get the relative location by which I want to shift my pivot. So here, that's what I'm going to do. I'm going to subtract the original location. Original location is going to be your, yes, this location is coming from uh, location, get location at distance along spline is from where I'm getting the original location. And this is now being subtracted by the relative mesh location, the offset. And this offset is going to ensure that your fence is going to always start from here, irrespective of what is the actual pivotal origin of your mesh. It is always going to start from the same look position. All right. So that's about it. And yes, for horizontal and vertical, if it is horizontal, then the dimensions is actually changing so that it switches back to horizontal. I will just quickly show you how this is working. If I set this to horizontal, you can see I also have to set the rest of the stuff as well. But that's the point. So I mean, it is shifting. It is changing its direction to horizontal instead. All right. So and it is being laid off like that. Obviously, I have not set up the horizontal part perfectly yet because I was concentrating on the vertical. But this is, you get the idea. So when this is working, so it is actually turning the uh, it is changing the dimension in a way that the horizontal dimension is more than the vertical dimension, because that's how it is going to make sense. But rest of the stuff, like it has to match the length and all, we will have to take that into account as well. But because we were just concentrating on the vertical, if you have seen the previous live stream, unfortunately it does not have any audio. That's why I have to rerun this today. So, but if you still take a look into that, so we were concentrating on setting up the vertical mesh. Anyway, for the secondary columns, I am again creating the fence column based on the location. So for the secondary column, you have to calculate the distance. So the distance of the current distance is going to be your, it is increasing to the next primary distance every time. Every time this uh, loop is this loop is running. So this while loop indicates that the current distance is less than the total distance, then it's always incrementing. So eventually it's going to be more than the total length, and this is going to stop. So the next distance is your current distance plus the distance of the main column, because your current distance, if let's say this one, this plus this is the distance between the main columns, so this becomes your next distance, and in the next iteration this becomes your current distance, and then this becomes your next distance, like that. So for the secondary columns, I have these parameters, dimensions I have chosen the orientation, and I have chosen the distance. If I increase the distance, so I increase the distance, number of secondary columns spawning is reduced. Right. Now, so if the secondary mesh info is valid, then I'm again running for loop over here, and for each of them, so for each of the secondary mesh, so I currently only have one mesh, but if I have more of this, then we have to then consider the other loops as well. So, but yeah, while secondary distance less than next primary distance, so the next primary distance is going to be this, and also secondary distance has to be less than total next one, and secondary distance equal to current distance plus secondary mesh dot distance. Secondary mesh dot distance is, let's say, 80. Current distance plus this is going to give you the secondary mesh distance. So, and this has to be between this. So, the secondary mesh is going to, for every primary mesh being generated, the secondary mesh is going to generate in between the given pair of primary meshes. So that's how this is being set up. So underlying the exact same functionality is also working over here. You can see. All right. So this is what we built last, last week, but unfortunately, it doesn't have any audio. So my what I was doing was clearly not understandable. So if you want to look into that, please, I mean, check that out as well, and you get the full explanation of what I was actually doing in this particular live stream, right? So that's about it for this. This is what I had made so far. So things which are remaining right now and I want to implement them include the wall dimension, like for example, the wall that would be occupying the entire dimensions along the line, apart from the end column. So the way it is going to work is, let's say this. So secondary distance is always incrementing by the distance of the secondary mesh. But if the distance of the secondary mesh becomes zero, this loop is infinite, which we don't want, obviously. That is going to create a crash. So distance of the secondary mesh can be, like for example, if the dimension is 15, and if it is something like 10, then these are overlapping, right? Too many of the meshes are generated over here and they are overlapping with each other. So what we can do, we can consider the dimension of the mesh into account as well. Okay? And how that will work, let's see. So here we are calculating the mesh column, but here I need to also consider the dimension, which is going to be the plus mesh of dimensions dot x, because it's going to be along x-axis, and here also it's going to be added. Now let's see what happens. field. Okay. Now we are going to be just will move this, I guess. This is now this is have a base distance of the dimension, and on top of that this distance is being added. So if I set the distance to 0, these are now going to exactly match. Okay. See, these are still not overlapping, these are exactly matching each other, because now this is also considering the dimension, right? So I also need to add a check so that it doesn't crash, because sometimes what happens, you can give the distance in a value that it is always, this is going to be always less than 0, and that's going to make this loop infinite. We don't want that. So I want to ensure that together these are well above 0. If greater than 0, then only let's do that, or else it will be going to moving on to the next mesh. So here also I will do a dimension check, dimension.x plus metal distance. So let me just add a main column with float value, where I can just simply copy this, because I'm using this multiple times. That's why if 11 see, also for here, we'll add this, and also for this case, we just added another one. Secondary, secondary column system. So this will be over here, also this will be over here, also over here. Alright. So let's just compile one more time. We increase the distance. Now we are going to handle the cases where there may also be horizontal beams along this. How do I do that? Let's check this out. Now we can just try this with this particular secondary mesh as well. Let's see, if I set this to horizontal, then only one is generated, which I don't want. I want more than maybe one, maybe five or six or something. In this case, the vertical row has to be considered, and also this is not coming right. We have to see what's the issue with the horizontal. Well, let's now look into the code for the horizontal. It is horizontal. Let's understand what's going to happen when it's horizontal. When I'm setting this to horizontal, first thing it should do, it should have the dimension along the length x-axis automatically calculated. So the dimension is going to be the distance along this. So when it is vertical, the dimension is not being used. We are just simply setting the dimension by ourselves and adding them as they are over here. But in the horizontal, the x dimension is typically between the two columns, two main columns. So, yeah, actually this logic is wrong, so we have to rewrite this logic. Not working way that we are looking for. So this we don't need to specifically set like this. We have to uh, define it ourselves. So let's just compile. That. Yes. So now for the horizontal, we need to what we can do. Let's see. So for the horizontal, the dimension is going to be the distance. It will be like, and the height. So this distance can be the distance between the two columns along the z-axis, and the maximum distance is going to be the height of the main column. So, so I'm just thinking, yeah, we need to first rotate the individual meshes if it is horizontal, and then we need to stack them one on top of each other. We have to calculate this in a way to make sense. So here, here So let's consider the primary column. It's a dimension along 250. So if it is horizontally spread, then the dimension along x is also going to be the is not going to be actually considered because it is going to be the entire distance. So we will set it like that. So when we are creating the mesh fence, if it is horizontal, then okay, we are yeah the dimension. Oh, so these are dimension horizontal. Then these are dimension dot x. Plus, let's keep the original dimension as well. Plus, let's not use the original. Let's figure that out later. These are dimensions dot x is going to be. We have to calculate the length. Length is the distance. So we are calculating the current distance from the main column dot distance. It's going to be the mesh info dot distance. So x is going to be all the way to here. Let's just check this out. Let's keep this vertical, this horizontal, and let's see what happens. It's also shifting its position, which I don't want. To see why it's shifting its position. I use rotation over here. Okay, now wall is not going to. We're also mixing up this. So this out. Something like Nothing over here. No. Let's switch that with our little bit. This is going to be fine. One more time. We have to rotate this. Rotation. Dot rotate. This. No, not this. Let's just remove this and be near. It is coming this way. Sorry. Yeah, it is matching the spline, but the yeah, original issue appears that the dimensions are different. So we have to figure that out itself. The question is here. That is I think location is coming fine. What I'm doing is I'm minus subtracting this with the rotate step. Location is coming fine, but the rotation is not correct. So this yeah this should be rotated this direction. This should be rotated along. This spline is actually very small for this rotation. If you increase the spline length, you decrease the spline points in the middle. So let's see if that's going to help. Add in spline point, you're going to yeah. This so the rotation is actually needs to be between the start and the end. Even if the spline point is smaller, for example, spline point is over here, then this rotation is also between the start and the end. So I cannot do it like this over here, get rotation or also get rotation. Instead, I need to get the look at direction. So let's add it over here. Then go to the direction equal to uh, okay, next location. I need the next location. Next location equal to next primary distance. Now I can get the direction. Effect the direction, float, length, and do it like this. Also, or I mean, I can do it like this. Next location minus location. I don't need to do this. I can simply do direction dot normalize. I think this will work. Location. Check it out. Hmm. I think it worked, right? Worked, but there is overlap between the two meshes. Yes, it is working. It is not working in this cases where for cases like this actually the this is becoming too smaller. So in this case we have to of course readjust our code so that these cases are also handled. Otherwise when the dimension is large enough, at least the main column is working perfectly. I can do the same for the secondary column as well. It over here. And this irrespective that normalize. Then I'm getting the secondary location. No, here I have to get the direction. Just bring everything back over here. Direction. This will be the secondary location. This is going to be the secondary direction. This I don't need. Let's just comment it up on. Yeah, it is fine. I mean, logically it's working, but it is not in sync most of the times. But because of the issue with aligning the vertical and the horizontal, so it says this to horizontal as well. Okay. Okay, look. So let's just figure this out for the main column. Here you have your spline. For this particular instance, you have the data. This is not how it should be. Whenever you have these cases, typically you would have the wall starting from here and then try and accommodate till here instead of having another wall adjusting over here. This is something that we need to figure out. Let's check out this. Let's set the dimensions over here to 0 for now. This made it like I really reduced the distance to something very minimal. Yes, secondary column is also dependent on the main column distance. So if you want to create the dimension like that, we cannot do it just that. Let's see. Let's say if I increase the distance, the wall is ongoing. The dimension is going to increase the horizontal one. So if I set the distance to be 0, it is coming like this. But it is incorrect. So because it should take the dimension into place. Let's say I had kept the dimension 250. Yeah, so it's completely wrong because over here, so I need to do the dimension plus x plus dimension to distance. Okay. Please calculating the dimension now. If the dimension is like 5 or 1 or even 0, it is gone, but if I am 25, the distance is also 25. Let's keep the distance 0 for now and set the dimension to something like 250. And now I will add a spline point and see how this works. This particular thing. I need to figure out this. If in this case where it is overlapping, you just have to figure that out. Let's just spend some time understanding the code and see how we can. If here I have deleted all the other points and only debugging with these two spline points. So if you see the walls, number of walls that should be created over here is actually two, one from here to here and then which is going to be simple enough, but here it's creating three. So let me see why it is doing that. That's because of this while loop, I think. Not this one, but this one. So for the first line, the distance is going to be, let's debug it. So I don't have to, anyway, let's understand this first. Then from the distance, then from the distance. Total length is going to be, so enter spline length. Um, Distance is also going to be fixed in this case. Next is text testing added from here. If I reduce the dimension, in that case, if I increase the dimension, it is going to add, it is adding another mesh actually, so we have to solve it. So when the dimension is 250, want this mesh to stretch till 250 in this direction. Then from here, maybe from this station, and then maybe from here another mesh is going to come. If this mesh has a distance of less than 250, in that case it should be an issue where that this mesh should not be valid, something like that. Okay, let's close this because we have to debug this and understand the exact values. Let's run this in debugger mode. Let's understand what exactly happening over here. Location is fine. The next distance is going to be difficulty. Next location. Actual distance between column and column. Now we are doing something over here. Let's take what you do. Oh, still not right. Finite while loops crashed. It's it again. So the issue is the dimension is still for this the dimension is actually more than the next line point. So for the next adjacent mesh, the direction is immediately changing for the spline, but the previous mesh is still having its dimension set out so that its direction is different than the next, so it's causing this issue. So we need to either readjust the next mesh so that it starts from the previous mesh. We can do that by This is going to be a clever move anyhow, so we can just simply add this previous position, and if the current distance is 0, then only we are getting the location as the line. Otherwise, the location is going to be the previous location. This is wrong. Previous end location would be location plus this one. The current location plus I also need the direction. So so this is going to be like the location plus uh, direction. Next, I completely missed it. Let's just investigate it. We can also do one thing. We can restrict the line or restrict the dimension till the next line point is coming, so that the dimension is always given mesh is always going to be the. Let's take this one. Dimension of a given mesh is let's just put it that way. So for this particular case, add a distance current distance. So we just distance dimension. Let's remove the distance factor from here. Yes, I'm getting a distance so that it's easier for me to understand now. It's actually 5. Now you can see this issue I have to solve. So there are two ways around. First, we can delete this altogether, the mesh that is overlapping, because I don't think we can. If it is smaller than this, then it's going to look too bad. And we can try that. We can probably add a threshold and make this up to user to create a even smaller mesh. So actually do that. I was looking for is for this mesh to start from here instead. If this is happening, that is what it need to be tricky for me. Okay, the secondary for now. Look for the primary one. Here in the next location, in the current distance equal to 0, then the next location is always the next primary distance. Keep getting the current location. The rotate for now. So the current distance is 0, equal to 0. Then I want the current location. It is the F previous location. Or if it's not previous, then I want the previous location. Previous location equal to location plus direction into main column distance. Let's check this out now. Yes, yes, yes. This is exactly what I was looking for. Perfect. Finally, this is yes. So it is ending from here and then it's starting from the next one. So, check this out. Yes. Yeah, it works perfectly. This is what I was looking for. Yeah, I should, instead of relying on ChatGPT, I think I should spend more time figuring out a solution myself. It's often faster. Right, so this part is working. Now, if we set the distance to 0, then it is a continuous. It is just like this wall that we were developing, a continuous data. Let's add some more scenarios and test cases to see if this is an issue. No, this is perfect. Now, how do I make it back to the fence that we have? Let's switch back the orientation to vertical. Now we have the distance is going to be like let's say 300. Yes, now it's back to what it was before. So both the logic is actually working fine. We have to do the same for the secondary column as well. We have to do the same for the secondary column. Consider secondary location equal to secondary distance. this initial case of secondary distance equal to this, then this is secondary distance, or else it is going to be previous secondary location. So we set this previous secondary location, previous secondary location. Here we will add this and we can delete this, and then rest of them are going to be fine. We'll check this out. I think there is some mistake. There is one, but the other ones are not generated. Okay, so I have to, yes, I was not setting the previous secondary location like I was setting this one. I have to set it like this. Previous secondary location equal to secondary equal to secondary location plus secondary location into I think it's going to be secondary column distance. Yes, now it is. I think this is a little isolated. So cases like this, so we have to consider the adjustment that we made as well. Let's see where we can adjust that. Okay, so here I'm not getting the next location. It's I have not done that. Next secondary distance equal to current secondary distance plus, yeah, it is fine actually. Secondary distance is the same thing. Okay, I think previous secondary location is going to be the really yes, let's just ask. I figured out the main column, which is now at the adjusted position of the previous columns in the while loop. The issue now is the secondary message should also be between the main column, but they are still following the plan. Still following the plan. So current distance column is primary distance and distance is primary distance. Okay, you have to do it here. Now, but you have to do it later, no? pressing. I think again for like just like what I had before, I have to figure it out myself. Let's do that. So let's reduce the distance. Let this to like this. Let's revisit the problem. Now the problem is that the mesh is adjusted, but the secondary columns are following the spline. Rather, what should happen? It should follow this start and end and also the direction. So distance. Next primary distance is working. So next, secondary distance equal to current distance. So previous secondary location equal to, okay, here I am making the mistake. I think I need to consider this uh, main column separation somehow for the direction calculation. This also for the while loop we need to this 5 secondary distance plus next primary distance is going to be, yeah, this is fine. While this is fine. Let's look into that. So this needs to be along this. Okay? So Initially, secondary location, if it is if the distance is this, then obviously first location is going to be the distance and spline. We can also do something like secondary location. So, the previous secondary location is going to be with this location. The secondary column location can be the previous, something like, or just location plus direction of the previous vector. I mean the direction between the next location and the current location for the main mesh into secondary distance. What if I do something like this? Let's see. Now let's check this. Oh, why did this happen? Maybe some world location and everything got off. Uh, fine. Okay, so zero. Initially the this is working here for this case, but not working for the other cases. I mean, it is going like this. It is not considering this at all. Initially it is perfect. Not exactly because there are maybe there are some issues over here as you can see. System plus direction into secondary distance. Let's just go back to what we have for now and try it once more with different strategies. Yeah, this particular case. Instead of starting from here, they are still starting along the line. It should start from here, right? So Oh, yeah, I got it. What if I add this over here? Now I think I am setting the previous location before so that now it is going to have the idea of where from where to check the next location. So previous location is going to previous secondary location. Yes, so secondary location is going to start from the location and its next location is going to be previous location. It doesn't make sense to have it over here. What I was thinking, it should start from the location over here, but I need to calculate the next location. So that's going to be location plus direction into next primary distance of simple. Then secondary location is going to be secondary direction is going to be this is the next location, right? So this is for also the direction. I can't get it like this. This would work. Location plus direction. Why it is not working? I also have to calculate the secondary next location. That's why secondary next location is going to be uh, it is going to be the same location plus direction into secondary distance should also be multiplied by 2 because it's going to be again multiplying with the secondary distance. Maybe it's going to be which is basically secondary location plus direction into secondary distance. Let's check. No, it's still not working as expected. Also for the alternate row, it's shifting to some. So let's just uh, so over here that I have the next location, I have the current location. So we can do something like instead of adding this while loop, let's just int calculate the number of iterations required, number of secondary columns. equal to uh, next location minus current location dot length, the total length of the difference divided by okay, let's keep this okay here divided by this. And now I can add a for loop to check our second columns. Um, can add this of course. For this I need the location if vector secondary location equal to is going to be the current location plus current location plus this is going to be the direction the previous into the distance, secondary column distance. Direction and if the next location secondary next location equal to secondary location plus direction equal to distance. And do it like this. Also I need to add the I index into I index plus 1. If I don't need this at all, let's comment this out. Now I think it seems to work. Let's check over here. I have the plan. Yes, yes, this is working now, but I see some issues over there, so we can fix that. Please fix yeah, we can fix that issue, but a major issue is solved, right? Let's just check few more time. Yeah, yeah, we are going to fix that issue, but at least it's exactly in the same direction. As you can see over here, even this is the same direction. Just add a point over here. Let's delete the other point so it's easier for us to debug. Now let me add a point over here. Yes. In this particular case, it is deleting. If I remove the reduce the distance to let's say 5, mm, this gap is still there. Okay. There can also be some gap in starting with. So for this particular mesh, for a given loop, it's always the first location plus the direction into secondary column distance into I plus. I think I need to get the it is rounded or something. No, round. That is not possible. If it's set to 0, then they are side by side still. Okay, I think because of this particular mesh which is generated from here instead of here, and still these are not generated at all. It is not working. At least the issue we had with the columns appearing over that is gone. But yeah, let's see that if that issue is still here. Or not. No, at least that issue is not here. What if I fail to? That's not an issue. The gap is way too much. Technical distance equal to secondary mesh distance plus secondary. Yes, it is fine. Next location. Uh, I will just do this. Minus location. And now simple. Maybe I will just multiply this by 3. So there are two main columns. See, start offset it away. Start point is location plus direction. Fine. Maybe it is something like 20 or 50 by 50. So here number of columns. Okay, let me get the distance a bit. 1, 2, 3, 4, 5, 6, 7. But here one 9 columns are there. Okay. Number of columns should probably be always same irrespective of which angle, but there the number of columns is changing based on the location, and that should not be the case. Let's just tell this to GPT. I think available space is going to be the main column distance. Um, Main column dot distance. Just you don't have to do this. Compare this. That can make it consistent. Yes, now it is consistent. Hmm, yes, I think it is now better. We can modify this further so that it doesn't appear at the end. To do it like if uh, current distance plus next primary distance, next primary distance less than total column, then only. So I think that is going to prevent the final columns to be generated. This columns. Yes. Now this is always the last. There is still so many things to be left for the frames. Like we can add the multiple niches horizontally and vertically, which we have done, but we have not yet tested them properly. We will do that, and also walls and then columns between walls and then gates in between. A lot of things are still remaining, so I will continue with this in one of the next live session. So I hope you really enjoyed this and you have possibly learned a lot from it. And if this is really useful live stream for you, please like and subscribe to my channel so that it motivates me to create more and more videos, tutorials, live streams. All right, so I will see you tomorrow.